Hey there, and welcome back. Today, we're going to add a real powerhouse to your calculus toolkit. We're mastering a technique called integration by parts. And trust me, it's going to turn problems that look impossible into ones you can solve in your sleep. Okay, let's jump right in. So take a look at this integral. How would you even start? If you're thinking about your usual methods, like a simple u substitution or the power rule, well, you're going to hit a wall pretty fast. And why is that? It's because we're multiplying two totally different kinds of functions here. We've got an algebraic function, x, and a logarithmic one, ln of x. Your standard rules just weren't built for this.
And that's really the heart of it, isn't it? When your current tools can't get the job done, you don't just give up. You find a better tool. And for integrating a product of functions like this, that special tool is called integration by parts. So here's our game plan. First, we'll talk a bit more about why that first integral is so tricky. Then I'll give you the formula that cracks it wide open. We'll do a full step-by-step example together. Then I'm going to show you a pro-level shortcut. And finally, we'll wrap it all up so you know exactly when and how to use this.
Okay, let's get right to it. It's time to unveil the core of this whole technique. This is the formula that's going to do all the heavy lifting for us. And here it is. The integral of u dv equals uv minus the integral of v du. Now, what's so cool about this is the strategy. You're not actually solving the integral head-on. You're treating it. You're swapping your original hard integral for a brand new one on the right side. The entire goal, the whole game, is to make sure that new integral is way easier to solve than the one you started with. And you can see it right here, taken directly from the source notes we're using. There it is, right at the top. Think of this formula as our master key. It's going to unlock every single problem we look at today. All right, enough with the theory. The absolute best way to get a feel for this is to just do it. So let's walk through our first example together, nice and slow, step by step. You know, it really just comes down to this simple four-step recipe. It's a totally repeatable process. You pick your u and your dv, you find their partners, du and v, and then you just plug all four pieces into the formula. Let's give it a shot. Okay, let's look at example 9 from the notes, the integral of x times cosine x. Now, the most important step is right at the beginning, choosing u. You want u to be something that gets simpler when you differentiate it. So x is a perfect choice, right? Because its derivative, du, is just 1 dx. Simple. That means dv is everything else, so cos of x dx. We integrate that to get v, which is just sine of x. Boom, we have all our parts. Now all we have to do is plug them into the formula and solve. See? It's that systematic.
And hey, don't go thinking this only works for indefinite integrals. If you've got boundaries, limits of integration from a to b, the process is almost exactly the same. There's just one tiny little addition.
Take a look at example 11 here. The setup, choosing u and dv, it's all the same. But look at that first term, the uv part. Instead of just being x e to the x, it has to be evaluated from the upper limit down to the lower limit. That's literally the only difference. You just evaluate that first chunk before you even worry about the second integral.
Okay, so you've learned the standard method. It's solid, it's reliable, it works every time. But what if I told you there's a faster way, a much faster way? For a certain type of problem, there's a pro-level shortcut that honestly feels a little bit like a magic trick.
This right here is the perfect motto for what you're about to see. This next method is all about pure efficiency, especially when one of the functions you're dealing with is a polynomial. So remember example 9, integrating x cos of x? On the left, that's the standard way we just did it. But on the right, that's the tabular method from example 13. I mean, just look at how clean that is. It gets to the exact same answer in like a fraction of the space and time. It's incredible. So how does this magic work? It's actually beautiful in its simplicity. You make two columns. In the first column, you put your polynomial, in this case x, and you just keep differentiating it all the way down until it hits 0. In the second column, you put the other function, cos x, and you integrate it the same number of times. Then you just multiply diagonally, and here's the key, you alternate the signs, plus, minus, plus. And that's it. You're done.
Now, the real power of this shortcut, it really shines when the problems get bigger. Imagine if instead of just x, you had x squared or x to the 5th. With the standard method, you'd have to do integration by parts over and over again. It gets so messy. But the tabular method, it just handles it. No problem.
Just check this out. Example 14. Our polynomial is x squared minus x. it looks way more intimidating, right? But with the tabular method, you don't even blink. You just differentiate that first column down to 0, integrate the second one to match, and then you draw your diagonal arrows, a few multiplications, and you've got the answer. This would have taken ages with the standard formula. Okay, let's bring it all home. Let's wrap this up and put these new skills into your own personal mathematical toolkit so they're ready to go whenever you need them.
So here are the big takeaways for your toolkit. Number 1, when you see an integral that's a product of two different kinds of functions, your brain should immediately whisper integration by parts. Number 2, remember the goal is to trade a hard integral for an easier one. And number 3, if one of those functions is a polynomial, for sure, save yourself a headache and use the tabular method. And finally, like any tool, the only way to get good with it is to actually use it. You gotta practice.
And speaking of practice, the best way to make sure you really own a new skill is to use it right away while it's fresh. So, what do you say? You ready to put this new tool to the test? Here's your challenge. This page from our source notes has 17 more problems, and they range from pretty simple to a bit more complex. This is your training ground. If you can work your way through these, integration by parts won't be some scary special technique anymore. It'll just be another tool in your belt that you know exactly how to use. Good luck.